In this video, we're going to be learning about rational exponents, which is a way to rewrite radicals. So the first thing that we need to understand is you can rewrite a radical using exponents, but these exponents are actually going to be fractions, or what we call rational exponents. So in general, if we have some nth root of x, we rewrite that as x raised to this fraction 1 over n. So just like in radical form for even roots, you have to include plus or minus when you're trying to solve. So if I have something like the square root of 36, there's really a hidden 2 right here. So this is the same thing as 36 to the 1/2 power. If I have the cube root of 64, this just becomes 64 raised, and now I look at this number, to the 1/3. If I have the 4th root of 16, this is equivalent to saying 16 to the 1/4. So now our exponents are actually fractions, which is where we get the term rational exponent. So we can simplify these in a few different ways. The first way, if I have something like 216 to the 1/3 power, I can rewrite that as the cube root of 216. And then I could always do my factor tree and look for groups of 3, and I would end up getting 6. So you get the same answer no matter which way you use. With something like this, where I have 7 to the 1/2 times 7 to the 1/2, notice I'm multiplying two numbers with the same base. When that happens, if I'm multiplying, I add the exponents. So 7 to the 1/2 plus 1/2 is really 7 to the 1st power, which is actually just 7. Now this next one, I can do a little bit of a trick. So I notice I have 5 to the 1/4 times 125 to the 1/4. Right now I don't have the same base, so I can't just add the exponents. But I do know that 125 is the same thing as 5 cubed. So let's see if we can rewrite this somehow to help us. So if I write 5 to the 1/4 times 5 cubed to the 1/4, the first thing, if I'm taking a power and raising it to a power, I multiply. So this becomes 5 to the 1/4 times 5 to the 3/4. And now, if I have the same base, I can add the exponents. So 1/4 plus 3/4. 1/4 plus 3/4 is just 1, so it's 5 to the 1st, which ends up being just 5. Now I have another rule. So this is my rational exponents rule. This is like the main rule. Right before this, we were just using a generalization. So if I have the nth root of a to the m, this is the same thing as saying a raised to the m over n, which is the same thing as the nth root of a raised to the m. So this can seem pretty confusing, but I like to think of this and this kind of meaning the same thing. Either I can raise m in the inside or the outside. Now, the way I remember this, if I am writing this out, I would write the n first and then the m second. This is just a quick trick. Now, if I'm trying to change it to an exponent, I do the opposite. I write the m first and then the n second. So it goes 1, 2, 2, 1. So let's try a few examples, then you'll see what I mean. If I have x to the 3/4, what I'm going to do is rewrite this. So I wrote 3 and then 7, so now I'm going to do 7th root of x cubed. Or I could do the 7th root of x and cube the whole thing. Both of these are equivalent. So all I'm doing is rewriting. I'm not actually changing anything. For this next one, x to the 3/2, well, I'm just going to write this as the square root, remember we don't usually write the 2, but I will for this case, of x cubed. So I write 3, 2, and then I write 2, and then 3. So I can rewrite this as just the cube root of x cubed. And last up, if I have x to the negative 7 halves, I just like to give the negative sign to the first number on top, so I'll make this a negative 7 over 2. Now I'm going to rewrite this as the square root of x to the negative 7, or that's just x to negative 7. I don't have to write the 2. So now let's try a few of these examples. So in this case, I'm going to be going backwards. So I have the radical, now I want to write it as an exponent. It's really helpful to put a 2 in here when nothing's there. So if it goes 2 then 5, now it goes a to the 5 halves. See how it's backwards order? In the next one, the 5th root of b to the 3rd is b to the 3 over 5. Last up, the 4th root of x to the 5th is x to the 5 over 4. So I write this one, then this one. Now it goes backwards. And all of the properties of integer exponents, or basically whole number exponents, apply to rational exponents. So anything I can do with the fraction exponents, I can do with whole number exponents. So now let's try to combine radical expressions with different indices. So you have to convert them to radical exponents to do this. So remember before, if we were multiplying, we didn't have the same index. Right now I have an index of 2 and an index of 4, so that doesn't help me. But let's see what happens if I rewrite these as fractional or rational exponents. This becomes 3 to the 1/2. Remember, if there's nothing here, it's really like a 1, so you can make it 3 to the 1/2, times 3 to the 1/4. Now I add the exponents. So when I'm multiplying, I'm going to add. So this becomes 3 to the 3/4, which then I could say is the 4th root of 3 cubed. And now it's combined. Next up, I have the square root of x cubed over the cube root of x squared. Let's try to rewrite this. Remember, there's nothing written, so 2. X to the 3 halves over x to the 2/3. So what I have to do now, if I'm dividing with the same base, I subtract the exponents. So what is 3 halves minus 2/3? Well, I'm going to have to convert this so I have the same denominator. So why don't I say x to the 9/6 minus 4/6, which is x to the 5/6. And now I can rewrite this as a radical one more time. So the 6th root of x to the 5th. So if we're simplifying numbers with rational exponents, we have 2 methods. The first is to change the base to its simplest exponential form and then simplify, or change the rational exponent into radical form and go from there. So if I see something like this, I'll show you the 2 ways for the first one. So 16 to the negative 2/5, negative 2.5, sorry. So let's change this into a fraction. Negative 2.5 is really like negative 5 over 2. So let's try to rewrite this as a radical. This is the square root of 16 to the negative 5th. Now, I don't really know how to deal with the negative exponent right there, so I'll put it in the denominator. I'll make this the square root of 1 over 16 to the 5th, which is the square root of 1, which is just 1, over the square root of 16 to the 5th. Now, what I can do is rewrite this into something that's easier to take the square root of. I could say 16 squared times 16 squared times 16, which is 1 over 16 times 16 times the square root of 16, which is 4, which is 1 over 1,024 if you do it out. So that way was pretty long. Let's see about this other way. The first thing I can do from this point right here, so I'm actually going to start here where I have a fraction, is I'm going to try to rewrite this So it's something squared because I have a square in the denominator. Well, I know that this is 4 squared, right? That's what 16 is, to the negative 5 halves. Now let's simplify this using our exponent rules. If I multiply 2 times negative 5 halves, I get 4 to the negative 5th, which is 1 over 4 to the 5th, which is 1 over 1024, just like before. So it's really up to you which way you're more comfortable with. Both ways will work. Let's try this next one. We have negative 32 to the 4/5. Well, negative 32, if I'm looking at this denominator, it's a 5. I kind of want it to cancel, right? So I know that negative 2 to the 5th is the same thing as negative 32. And now I'm going to raise it to the 4/5. Now I'm going to multiply, so I get negative 2 to the 4th, which if I multiply that out or multiply my calculator, I will get positive 16, because an even exponent gives me a positive number. Let's try one more. So in this one, I have a decimal, so I'm going to change this into a fraction. So I'm going to rewrite this as 9, let's say, to the negative 7 over 2. Now look, I have a 2 in my denominator. Can I write 9 as something squared? Well, yeah, I can write this as 3 squared, and I'm going to keep my exponent of negative 7 halves. Now if I multiply it out, I get 3 to the 2 times negative 7 halves, which is 3 to the negative 7, which is 1 over 3 to the 7th. You can multiply it out, or I'm totally fine with you leaving it like that because 3 to the 7th is a little bit big. So last up, we're going to try to simplify things, and these can look really overwhelming at first. So I have a mix right here of radicals and rational exponents. In my opinion, it's usually a little bit easier to work with the fractions first. So I'm going to change everything so they have fractional or rational exponents. So I'm going to rewrite this as negative 8x, and I'm going to write this radical as xy to the 1/2, and the whole thing still raised to the 2/3. So now I'm going to try to raise everything to the 2/3 power. So this is going to be negative 8 to the 2/3, x to the 2/3, and xy, now I multiply, to the 2/6. So I end up with negative 8 to the 2/3, x to the 2/3, x to the 1/3, y to the 1/3, because 2/6 simplifies. So again, I can do a few things here. So I'm going to combine my x's. So I'm going to say negative 8 to the 2/3, x, y to the 1/3. The last thing I need to figure out, I've kind of been putting it off a little bit, is this negative 8 to the 2/3. So there's a few ways I can do this. One way is that I know negative 8 is the same thing as negative 2 cubed. And I'm still raising it to the 2/3. So if I do this, these cancel when I multiply. I end up with negative 2 squared times x times y to the 1/3, which is 4xy to the 1/3. So I can either leave it like this in simplest form, or I can put it back into a radical. So I can write this as 4x cube root of y. Those are both our simplest form. Let's try this last one. Again, it can look really overwhelming at first, but just break it down part by part. So first thing I'm going to do is distribute my negative exponent. So I'm going to make this 16 to the negative 3/4 times y. Now negative 8 times negative 3/4 is going to be 24 divided by 4, which is 6. So the last thing I have to do is figure out the 16. If I look, my denominator is 4. Can I write 16 as something to the 4th? Yeah, I can write it as 2 to the 4th. Now this becomes to the negative 3/4 times y to the 6th, which if I multiply these, I get 2 to the negative 3rd, y to the 6th. 2 to the negative 3rd, I can put in the denominator as 2 to the 3rd. 2 to the 3rd is 8, so I get y to the 6th over 8.